Hi, I'm Richard Llewellyn from Bioresources. This little video covers the development and use of Anastatus wasps as a biocontrol agent for fruit spotting bugs. Back in 2010, we were encouraged by a group of growers to look into biocontrol of fruit spotting bug. The trichogramma wasps we call Mactrix for macadamia nut borer had been so successful that growers were saying, so what about fruit spotting bug? We launched into a one-year HAL voluntary contributor project to set up a large fruit spotting bug culture and to start assessing suitable mass-rearable biocontrol agents. We knew it would be a challenging project, and at that stage we had no idea where it would go. So I'll outline the steps we took and how it all evolved. Each step needs to be ticked off before going on to the next. Firstly, we establish a culture of the target pest to use to catch parasitoids and do experiments. Secondly, we need to identify suitable candidates. We might do this through the literature or from our knowledge already of things in the field. We need to have an eye to effectiveness, mass rearability. Once we've narrowed it down to a candidate or two, we need to figure out how to rear these in the laboratory. This is not large-scale rearing, this is small-scale rearing at that stage. Then we conduct laboratory and greenhouse tests. We look at life cycles, temperature tolerance, etc. And then we can move on to small-scale field trials in single trees and groups of trees. But to do larger experiments, we need to have a reliable mass rearing system. So this is quite a major undertaking, this part, to develop a reliable system. If we cannot get past this hurdle, then conducting longer term farm assessments is not practical. So that's a very important step and has obvious bearing on the long-term viability of the product. I'll work through these steps and then talk about the release strategies and methods. But first, I'd like to talk about the culprits themselves. Fruit spotting bugs, Amblypelta nitida, and banana spotting bug, Amblypelta lutescens, are clearly challenging pests. They're relatively long-lived and move around the local environment, moving from one food source to the next. And a relatively small number can cause a lot of damage to a wide range of crops. Both species go for the fruits of avocado, macadamia, lychee, custard apples, stone fruit, figs, persimmons, and lots of tropical fruits. While banana spotting bug also goes for the shoots of mango, passion fruit, avocado, and papaya. And surprise, surprise, it also spots bananas. Both species have lots of alternative hosts in gardens and orchards and around the edges of farms in nearby bush and along waterways. This is a list of some of the common host plants for spotting bugs. There are many more than that they can feed on, but they mightn't breed so well. Under a microscope, there are various features that distinguish the adult species, but in the field they look very similar. Banana spotting bug has a slight orange tinge to it, and fruit spotting bug may be greener and a little darker. The hatchlings are similar, but in the later nymphal stages, banana spotting bug are broader and have distinct white bands around the two black spots on their back. Only fruit spotting bug is found south of the Tweed River, while both species are often found together in Queensland crops. But generally, it's dominated by banana spotting bug as you go further north into the hot humid areas. Bug eggs, the target of egg parasitoids like Anastatus, are oval, 1.5 millimeters to 2 millimeters, pale green, and rarely seen in the field, even by crop consultants. Bug hatchlings hatch in about 6 days, and their antennae are visible through the egg chorion before hatching. Nymphs go through several stages to adulthood, and that may take 6 weeks or so. So unless spray coverage is very poor, most of the adults seen in sprayed crops are likely to have flown in from nearby bush or other crops or house gardens. Both nymphs need appropriate food sources to develop to adulthood, and the adults need even more suitable food sources before they will lay eggs. Although they may damage fruit, they may not lay many eggs. As bug nymphs cannot fly, they are very susceptible to predators, especially spiders. I took these pictures in my home garden orchard, so it was clear to me early in this project that spiders are a significant predator of spotting bugs and likely to make a useful contribution if they're given a chance. So, like most pests, spotting bugs have natural enemies. There are several egg parasitoid wasps, some phorid flies, perhaps a tachinid fly parasitoid, and some other predators like assassin bugs, and also probably birds as well, as they've been reported feeding well on green veggie bugs. Our task was to find one that was effective and mass rearable in large numbers. Back in the 1990s, Harry Fay, a DPI entomologist at Mareeba, had identified a number of egg parasitoids, including Anastatus, and he did some testing in the laboratory and in a greenhouse. And he concluded that Anastatus was a good candidate if it could be mass reared. I'd started looking in our house orchard at Mount Sampson, just north of Brisbane, and found my first Anastatus wasp that came out of spine citrus bug eggs. We were then able to collect some more of these wasps and keep them going on fruit spotting bug eggs. Meanwhile, we were able to collect Anastatus in Mareeba by putting out some fruit spotting bug eggs in marea hedges and fruit trees around the town. The species of Anastatus I had collected in the backyard turned out to be different to the one Harry Fay had worked with. We did some comparison trials, and although both were able to find and parasitise fruit spotting bug eggs, the North Queensland species may have been a little better. So we thought it best to work with the same wasps as Harry, as he had already shown it was a good one for fruit spotting bug. The female Anastatus wasp is about 4 millimeters long, and it can be mistaken for an ant. Females hold their wings very close to their body, and they constantly walk across leaves, but less frantically than ants, and unlike ants, it can hop and fly between trees. It flies more readily at temperatures over 23 degrees, and in cooler temperatures it may stick around in a tree for a week or more if there are bugs about. The females may live for several weeks, and they could travel hundreds of metres in that time. They're capable of parasitising 30 or more eggs. The males are much smaller, and they have more prominent wings are perhaps a bit more wasp-like, and they don't live nearly as long as the females. They both feed on nectars and insect honeydews, and the females use their sensitive antennae to detect likely environments, perhaps nectar and bug scents, to gradually move towards likely bug areas so that they can find some eggs to parasitise. In the early stages of the project, we were investigating the possibility of rearing Anastatus on fruit spotting bug eggs. So we established what to us was a big culture, but found that even producing, say, 2,000 eggs per week was much too much work. Nowhere near enough for a commercial culture. Harry Fay had mentioned in a paper that the Chinese had been rearing Anastatus on silkmoth eggs to target lychee stink bugs. We managed to track them down and make contact, and they turned out to be really helpful. After we got the quarantine clearance, they shipped us a kilogram of eggs to test out. And on looking at the eggs, I thought, these eggs are so tough, there's no way these wasps are going to be able to parasitize them. Under the microscope, we watched the first wasp bore through the egg shell. We had to wait another 3 weeks to see if they could cut their way out of the egg, which they managed to do. This was a big breakthrough, and the prospect of efficient mass rearing all of a sudden became very real. So I organised a trip to China, where my new Chinese friends showed us around. Anyway, we ended up importing more silkworm eggs and started developing our rearing system. At this stage, our little project merged with the new Howl multi-industry fruit spotting bug project. Now we needed to find out more about the behaviour of Anastatus, both in the rearing facility and in the field. As Anastatus is a reasonable size, we cannot coop them up too much, and in the rearing system they need space, otherwise they can disrupt each other when laying eggs. We've had to work around this in developing our system. Along the way, we also found that the Anastatus wasps that we're rearing also parasitise green vegetable bug eggs, but we found that only males resulted. The eggs are perhaps too small for the development of the larger female wasps. Nevertheless, this stops the bugs hatching from those eggs and may be useful in IPM crops and glasshouses like capsicum, where the sprays for GVB are disrupting the other biocontrol agents.